Welcome to the third video of Module 3. In this video, we will discuss naming inorganic compounds. The learning outcomes for this part are to learn how to name ionic and molecular compounds, write the formula for ionic and molecular compounds from a given name, and name certain acids and polyatomic ions. The term nomenclature means that you need to learn how to name compounds when given the chemical formula and how to write the chemical formula from the compound name. First, we'll learn how to name binary compounds. The term binary compound means a compound made up of only two elements. Remember that we have two types of compounds, ionic and molecular. In Module 2, we mentioned that ionic compounds are formed when a metal binds to a non-metal. Metals form cations, so they carry a positive charge, and non-metals form anions and carry a negative charge. They then join together by the forces of attraction to form a compound with no charge. So the charge from the cation should neutralize the charge from the anion. To name these compounds, we follow these steps. First, we write the name of the metal element with no change in the name. Then we write the non-metal name. Here we need to change the last part of the element name and add "ide" instead. Let's look at some examples. NaCl. The metal is sodium and the non-metal is chlorine. We keep the metal name without any change, sodium. We change the non-metal name and add "ide", so chlorine becomes chloride. Thus, the name of this ionic compound is sodium chloride. Pause the video and try to name the following compounds. The answer will be revealed after you continue. CaBr2 is called calcium bromide. MgO is called magnesium oxide. And Ba3P2 is barium phosphide. So naming ionic compounds is fairly straightforward. Now let's learn how to write the chemical formula from the compound name. To do that, we need to follow these rules. First, write the formula for the metal ion, followed by the formula for the non-metal ion. Second, combine the smallest number of each ion needed to give the charge sum equal to 0. Finally, write the formula for the compound as the symbol for the metal and non-metal, each followed by the subscript of the number determined in step 2. Let's see an example. Write the formula for calcium chloride. From the name, we determine that the metal is calcium. By looking at the periodic table, you see that calcium is located in group 2A. Thus, it has 2 valence electrons, and losing those electrons will give the calcium a stable structure similar to argon. So the calcium cation has a positive 2 charge. Now let's look at the non-metal part of the compound, which in this example is chlorine. Chlorine is located in group 7A on the periodic table, so it has 7 valence electrons, and it needs 1 electron to achieve stable structure similar to argon. Thus, chlorine forms an anion with a -1 charge. Remember that the compound should be neutral, so we need 2 chloride anions to neutralize the 1 calcium cation. Therefore, the formula for this compound is CaCl2. We will practice more examples in the tutorial sessions. Now let's discuss how to name ionic compounds that can contain a transition metal that can have more than 1 charge. Remember from part 2 of this module that some transition metals might have more than 1 charge. For example, iron can be either Fe2+ or Fe3+. Copper can be either Cu plus or Cu2 plus. So how can we name the ionic compounds that contain a transition metal that can have more than one charge? The process of naming these compounds is similar as before. However, we also need to show the charge of the transition metal in the name of the compound by using Roman numerals. For example, FeCl2. Because iron can take either positive 2 charge or positive 3 charge, we need to indicate the charge for the ion when naming this compound. The main task when naming those compounds is to determine the charge of the transition metal. And to do that, we need to look at the other element, the non-metal, in the compound. An example is FeCl2. The non-metal is chloride in this compound. As the chloride ion has a -1 charge, we need 2 atoms to make the compound neutral. Therefore, the ion has a +2 charge in this case. So we reflect that in the compound name by including the Roman numeral for 2, and consequently the name of the compound is iron 2 chloride. Likewise, if you are given the name of the compound, you need to predict the chemical formula for this compound. For example, write the formula for copper 1 chloride. From the name, we know that the copper took a +1 charge in this compound, so it has the formula of CuCl. We will cover more examples of naming and writing formula of ionic compounds in the face-to-face tutorial. The second type of compounds are molecular compounds, which form from 2 non-metal elements. To name these compounds, we follow a similar way as before, but we also need to include prefixes. So we write the name of the first element using a prefix if there is more than one atom of this element. For the second element, we need to change the last part of the name to "ide," like we did in the ionic compounds. And also, we need to add a prefix to indicate the number of atoms for the second element. We use the prefixes mono, di, tri, tetra, etc. when naming these molecular compounds. Take the compound CO. The first element is carbon, and there is only one atom, so we don't need to use the prefix. The second element is oxygen, so first we need to change the name to oxide. Second, we need to use the prefix to indicate how many atoms of oxygen are present. As we have one oxygen, then the compound can be named as carbon monoxide. Now let's try CO2. The first element is carbon, the second element is oxygen. As we have 2 oxygens, then the compound can be named as carbon dioxide. Pause the video and try naming the following 2 compounds. N2O is named dinitrogen monoxide. N2O4 is named as dinitrogen tetraoxide. Likewise, you need to learn how to predict the chemical formula of the compound from its name. For example, phosphorus trichloride. From the name, we know that we have only 1 atom of phosphorus and 3 atoms of chloride, so the compound is PCl3. Sometimes we use common names for frequently used compounds. For example, H2O. We don't usually name it as dihydrogen monoxide, we call it water. Another example is NH3, which is called ammonia, and we don't need to use the proper naming system. Some compounds consist of 2 parts, with one part coming from a polyatomic ion. The term polyatomic ion refers to an ion that contains more than one element. To name these compounds, we follow the same rules as naming ionic compounds. We name the cation first, then we name the polyatomic ion. Therefore, you need to learn the name of those polyatomic ions. You are only required to learn 6 for the purpose of this course, and they are SO4 sulfate, NO3 nitrate, CO3 carbonate, OH hydroxide, PO4 phosphate, and NH4 ammonium. We also need to learn how to name acids. For the purpose of this course, you only need to remember 3 acids that we use regularly in the lab: hydrochloric acid, sulfuric acid, and nitric acid. How are these acids named? Let's look at them one by one. Hydrochloric acid is the simplest form of an acid, and to name these types of acids, we follow the following steps. The first part of this simple acid is a hydrogen element, so we name it as hydro. The second element is chlorine, and it becomes chloric. We add acid at the end of the name, so the name becomes hydrochloric acid. The other 2 acids are more complicated, as the second part of the compound is actually a polyatomic ion. So to name this acid, we need to look at the polyatomic ion first. Sulfur can have 2 different charges when it is part of a polyatomic ion. The first polyatomic ion it forms is SO4 which is called sulfate. When it joins a hydrogen element, it forms a compound called sulfuric acid. Sulfur can also form SO3 which is called sulfite. When it joins hydrogen, it becomes sulfurous acid. Nitrogen also forms 2 polyatomic ions. The first, nitrate, has the formula NO3-, and it forms nitric acid. The second is called nitrite and has the formula NO2-, and it forms nitrous acid. Now we finish the content for part 3 of module 3. In the next few slides, we will summarize the key points and concepts for this module. Let's summarize module 3. In the first video, we covered the subatomic materials and said that there are 3 types of subatomic particles: protons, which are positively charged, neutrons, which are neutral, and electrons, which are negatively charged. We also mentioned that according to the Rutherford model, these particles are arranged in a certain way inside atoms. So we find the neutrons and protons in the nucleus, and the electrons are circling around it. We also discussed that the mass of an atom comes from the nucleus, that is, the total number of protons and neutrons, and we ignore the mass of the electrons as they are very light. We also introduced the nuclide symbol that consists of 3 parts: the element symbol, the atomic number, or the number of protons, and the atomic mass. It is important to remember that the number of protons is called the atomic number, and this number determines the identity of the element. We also discussed the isotopes and mentioned that for any element you might find different isotopes in nature. We defined isotopes as an element with the same number of protons but different number of neutrons. Isotopes have different abundances in nature. Therefore, in the periodic table we present the average atomic mass of the isotopes, taking into consideration the abundance in nature. For that reason, you find that in the periodic table, the atomic mass value has a fraction due to the calculation method. The final concept we covered in this part was the atomic mass unit. We mentioned that the standard for this unit is the isotope carbon-12. So one atom of carbon-12 weighs exactly 12 AMU, and there is no significant figures in this case. All other atoms are measured compared to this standard. In the second part of Module 3, we discuss the energy levels of atoms. There are 4 quantum numbers to describe the electron energy state in an atom. The first number is called the principal quantum number, or the shell. The second is the subshell. The third number refers to the shape of the subshell, or what we call the orbital. And the final number is the spin. The first energy level, N1, is called the ground state, with one subshell, S. The shape of this subshell is a sphere, and the spin is represented by an up or down arrow. N2 is a higher energy level called excited state and has 2 subshells, S and P. 2s has a sphere shape, whereas P has a more complicated shape and has 3 orbitals. Remember that those 3 orbitals are identical in terms of the energy level, but they have different orientation in space. The spin is the same. After that, we discussed the electron configuration and orbital diagrams, and the guidelines to fill in the energy levels. We said that only 2 electrons can occupy one orbital, so in the s orbital we can fit 2 electrons only. However, in the p subshell we have 3 orbitals, so we can fit 6 electrons. We also mentioned that in higher energy levels we start to have exceptions, and the first exception happens when 4s orbital is filled with electrons before 3d. After that, we discussed the periodic table in terms of the electron structure and explained how elements are positioned in the periodic table. We also discussed the concept of valence electrons and defined them as the electrons situated in the most outside shell. Valence electrons are the ones that get involved in chemical reactions. Finally, we discussed how you can use the periodic table to predict the charge for the groups close to the noble gases, such as groups 1a, 2a, 6a, and 7a. We mentioned that for the other A groups, it becomes harder to predict the charge. Also, we said that for the transition metals, you need to learn the charge of those elements, as there is no way to predict from their position in the periodic table. We finished the lecture by saying that some transition metals can take up to 2 charges, and you will need to learn those as well. In the third part of Module 3, we looked at naming the inorganic compounds. The first task is to determine the type of your compound. So you look at the first element. If it is a non-metal, then you have a molecular compound. To name these compounds, we use prefixes. An example being phosphorus trichloride. If the first element is a metal, then you have an ionic compound. Before you name the compound, you need to decide whether the metal can take only one charge or can take more than one charge, like certain transition metals. If the metal can take only one charge, we name it first, then we name the non-metal by adding "ide". An example of this is aluminium chloride. If the metal can form more than one type of cation, we need to use Roman numerals in the naming system to indicate the charge of this metal. Remember that you can predict the charge of the metal by using the non-metal element. An example being iron 3 chloride. Finally, here are the 6 polyatomic ions and 3 acids that you need to learn for this course. This is the end of Module 3. Please practice the weekly exercises in your textbook and the questions you find in your workbook. We will meet face to face in the tutorial session, and this will be your opportunity to ask any questions or for any clarification.